This video we are discussing about relative motion. First of all, you have to understand what is the relative motion is. I know most of you are aware of that. The motion of a body with respect to another body is said to be the relative motion. Okay? Relative motion can be understood in three different ways. One is relative to their positions. The second is relative with respect to their velocities. And third one, relative with respect to their accelerations. I mean, relative motion can be understandable by three different ways: with respect to their relative positions, by choosing the position vectors. The second one, relative velocity. And third is the relative acceleration. To understand this topic in right way, first we have to know what is the frame of reference. In previous topics I explained you, we have different kinds of frames of references. Such one frame of reference is ground frame of reference, I said. Okay? Here, I already told you we are discussing about relative motion. Okay? To understand this in right way, first locate a coordinate axis system. Okay? We have, as usual, it is x-axis and it is the y-axis. Say it is origin and say it is ground frame. It is the ground frame. It means what? We are observing the position of the body. What is it with respect to this ground? Now think, an aeroplane is flying here. I am calling aeroplane, it is A, isn't it? And a balloon is here. Okay? For balloon, we call it as B. Okay, students? Here there is a probability of observing the aeroplane in two different ways. Getting me? Here with respect to the balloon, with respect to the ground. Okay, students? Right now, what I am doing, I am connecting A and B with a position vector. Okay, I am writing it as R bar of AB. Okay, students? Here, the motion of the aeroplane has been observed by the balloon, the person in the balloon. That means what? The position vector we took. In the same way, I am connecting A to ground. Okay? It is the balloon which is observed by the observer at ground frame and shown with a vector. Okay? I am writing it as R bar B of G. Here or BG with respect to the ground. The position of the B with respect to the ground or observer, you can say. The two have been added. Then what I am doing? I am connecting A and as well as the observer or the ground. You can write it as R position vector I am taking of A with respect to the ground. I hope you are understanding. What I am doing now? Just I located the position vectors. I took a frame. I said it is the ground frame. Here, particle A is here and a body B is there. Here, to understand easily, I said it is the aeroplane, it is the balloon, it is the ground. Here, the position of the aeroplane with respect to balloon is taken as position vector A of B. Similarly, the position of the balloon or the body, you can say, with respect to ground is shown as R of B of ground. And here, the position of the aeroplane with respect to the ground frame is written as R bar H. If you watch it carefully, you will find we formed a triangle. See this? Now, recall the basic addition in vectors. We have a law to add the two vectors, and you know that it is the triangular law of vector addition. The law can be stated like this. If the two vectors are shown as the two sides of a triangle in an order, the closing side of the triangle is the sum of the two other vectors in opposite order. Students, here it can be stated like this. Two vectors, that is here I am showing, it is RB of ground and RAB. These two position vectors are shown as the two sides of the triangle in an order. If you watch it carefully, the order is what? It is the clockwise direction. The closing side of the triangle is taken by the other vector which is in opposite order. If these two are in clockwise direction, the resultant might be in anti-clockwise direction. Understanding me? Here I am writing the notation I am adding actually. Here relative motion is nothing but the vector addition. Here R bar of B with respect to ground, the other side plus R bar of AB might be equal to R bar of A of G. Or it can be written as R bar of AB, relative velocity of A with respect to B, or relative position of A with respect to B. Here we are talking the positions only, is equal to R bar A of G minus R bar B of G. Getting me? Here we can find the position vectors in such way. Here we took the ground frame as the reference. That's why I am just ignoring the G, ground. Then you can write it as R bar AB might be equal to R bar A minus R bar B. Students, it doesn't mean that there is no, what's that, presence of the G there. J is invisibly there. It is showing that position of the A with respect to ground, position of the B with respect to the ground, But here R bar AB is equal to relative position of the A with respect to B. In this way, you can write the vector. It is nothing but the vector subtraction. You can understand it very easily. RA, A, B, followed by B. Here, to get the relative velocity, what you have to do? We have to differentiate it. Say it is one. Okay, students, getting me? Okay, differentiating equation 1 with respect to time. What we get? D by dt of R bar AB is equal to d by dt of R bar A plus d by dt of R bar B. You know that rate of position is velocity. You can write V bar AB is equal to here minus, okay, V bar B. It is the desired equation. Okay. In the same way, again differentiating with respect to time. Okay, that is d by dt of V bar AB is equal to d by dt of V bar A minus d by dt of V bar B. Okay, rate of velocity is acceleration. You can write AB is equal to A B. In this way, you can find out the relative velocity or relative position or the relative acceleration in one dimension. What I have to say here, actually it is incomplete without writing relative motion in one dimension. Okay, students. Okay, students. I hope you understood how to find out relative acceleration, relative velocity and relative position, okay, in terms of relative motion in one dimension. I hope you carried the class. In next video, we are going to learn about relative motion in two dimensions. Thank you for watching my video. If you feel it is deserved, subscribe my channel